So go to your last page. We're going to address that one first. So the corollary to the base angle theorem is a corollary is just a theorem that has been proven using a previous theorem that has already been proven. So we already did the base angle theorem, which states if I have congruent sides, then opposite those sides are going to be, the angles will be congruent. So for the corollary of that theorem, if I know a triangle is equilateral, then it's also equiangular. So in order for you to be an equilateral triangle, that means you have to have 3 congruent sides. So if I see 3 congruent sides, then I can conclude there are 3 congruent angles. So on number 5, they want us to find the value of each variable given the fact that we have 3 tick marks, proves that we have 3 congruent sides. So if I give you the sides, you're going to fill in the angles because the angles are congruent as well. So each angle here, if they're all congruent, it's 60 degrees. Yes, 60, 60, and 60. So you have to know if the triangle is equilateral, then it's also equiangular. And if it's equiangular, each angle is 60 degrees. So that lets me set up my equations for each variable. To find x, we're going to write 5x plus 25 equals 60. And then we're solving for x. So we're going to subtract the 25 to isolate the 5x term. We get 5x equals 35. So x equals 7. We're going to do the same thing to find the z. Z is 32z minus 4. That angle is also equal to 60. So the equation is going to equal to 60. We add 4 to both sides, so our 32z equals 64. So z would equal 2. And then to find the y, our 4y is going to also equal to 60. Yeah, y is going to equal to 15. Yes. And we're done. But you have to use the fact that it's equiangular, the 60 degrees, the inside, to find each measure. All right, so on number 6 here, we're just doing the converse of the theorem. So we're just switching the facts around. If it's equilateral, then it's equiangular. Well, then if it's equiangular, it's also equilateral. Oops, let me move this up. All right, so on number 6 here, we just switched it around. Equiangular, then it's equilateral. What does equiangular mean?
3 congruent.
Yeah, 3 congruent angles. Okay. So if I see 3 congruent angles, then I know I have 3 congruent sides. So on number 6, it's asking us to find the perimeter of the triangle, but it's giving us 3 congruent angles, which means there are 3 congruent sides. So in order to get to the perimeter, I have to find the x. So what's our equation we can write here? What do we know? We have 3 congruent sides, guys. Yeah, that's true. Each angle is 60. But where's the expression? What is the expression? Because what does this represent?
Base.
Okay, and what does this represent? A side, okay. The base is also a side, right? So what do we know about all the sides? They're congruent. So our equation would be make the two sides congruent because they're all congruent. All right, solve for x. Start with your smallest variable. Solve for x. Yep, x is 9. Okay, now to get to the perimeter, we need to know what the side is. So we have to plug it back in. So we can have 6 times 9 plus 16. Yep, this turns into 70. So each side is the same, which is 70. So our perimeter, P for perimeter, let's just take the 3 sides, times it by 70. Our perimeter is 210. All right, so this flip book is going to go on our next available page. And then we're going to move to the guided practice.